Now that we have all of the machinery of SL in place, I'm going to work through some sample sentences so that we can see how more complicated sentences or compound sentences can be translated using the basic machinery. Rather than just working through this in sort of the virtual whiteboard, the way I've been working through the last few videos, I'm going to do this in Carnap so that you can also see how that program allows you to enter your own answers when you go to do the homework. So here's a Carnap file. This isn't one that's exactly the same as the homework, but it's the same kind of format. We start with a symbolization key. We have 3 atomic sentences, C, J, and L. C means Charles likes peas, J means Jean likes peas, and L means Logan likes peas. And the task we're given is, using this given symbolization key, translate the following sentences. The first sentence is, peas are liked by Charles. Okay? So for that, the answer is just C. That's just the same as saying Charles likes peas. And if we go to submit, it says, not finished yet. Remember to press return. Oh, okay. So we go back here, we press return, and Carnap tells us, yes, that's a perfect match. That's the answer. We got it right. So on the homework problems, when you're asked to translate, Carnap will check your work and it'll let you try again if you got it wrong. So you're not penalized if you get it wrong. It just, in order to submit it, you've got to figure out what the right answer is. Obviously, exams won't work that way. But for the homework problems, Carnap will help you along. All right, so we got the first one. That was easy. For the second one, Charles likes peas, however, Jean does not. Well, we've got C, Charles likes peas. We've got J, Jean does not. And remember that we can use the ampersand, and Charles likes peas and Jean does not. This is sort of like a sentence with a but in it. Charles likes peas, but Jean does not. So we need the not too. Can't forget that. So what we've got is Charles likes peas, and it's not the case that Jean likes peas. Perfect match. Good. Next one. If Logan likes peas, then so does Jean. L, arrow, J. Notice I typed a dash greater than, and Carnap, as I'm typing, it auto-translated it to an arrow. No problem. Good shape. Next problem. Either Logan likes peas or he does not. That's going to be Logan likes peas or Logan does not like peas. Perfect match. Notice on this one, I put in some spaces around the or, and that doesn't really matter. Notice also we have an alternate way of symbolizing, or we can use \/ That's fine too. Okay. Now, number 5, neither Logan nor Jean likes peas. One way to think about this is, well, it's not the case that Logan does, and it's also not the case that Jean does. So we do it this way. Nope. There. Not L and not J. Carnap says this slightly strange thing. That's logically equivalent to a standard translation. That means it's a right answer. For any of these problems, there are multiple possible answers. And provided what you've written is logically equivalent to a standard translation, it's a right answer. It's a way of translating that sentence. And this is a perfectly good one. You can say, when you have a neither nor sentence, you can translate that as not the first one and also not the second one. Notice I didn't write in parentheses, but I could have done. And if I did, they'd go around the whole thing. Carnap's still happy with that. Okay. Now, neither nor, you might think about it in a different way, though. You might want to translate it in terms of a disjunction. Neither nor is kind of like either or in English. So it's neither Logan does nor Gene does. And if we do that, what changes is where the negation has to go. It's not the case that either Logan or Gene does. And for that, we put the negation on the outside of the parenthesis. It's not the case that whole thought, Logan or Gene does. Carnap says, perfect match. So that would also be a right answer. This is a case where there are multiple possible right answers, and because they're logically equivalent, they're all equally good. To make that point again, let's look back at number 1. The simplest answer was C, Charles likes peas. We could have said, though, Charles likes peas and also Charles likes peas. Carnap says, logically equivalent to a standard translation. That's a perfectly good answer, too. Okay. Now, as we move through the problems, we're getting to some harder ones. Neither Logan, Gene, nor Charles likes peas. All right. We could think about that the first way we thought about the other one. We could do not L and not J and not C. Carnap says, yes. Or you could think about it the way we thought about the second one. It's not the case that, here there's a big disjunction, L or J or C. Carnap says, that's good too. Okay. Number 7. Charles and Logan agree about peas. Well, now, we can't capture agreement across all questions. Given our symbolization key, there's a kind of a presupposition here. They agree in liking or not liking peas. Now, one way to translate this would be Charles and Logan, well, if one of them likes peas, the other one does. And if one of them doesn't like peas, then the other doesn't. That is, they like peas if and only if the other one likes peas. We can translate that with a biconditional. Next one. At least one of Charles, Gene, and Logan likes peas. So that means, well, we can't capture this exactly. We can't do math in SL, really. At least one. We can't say the number of people who likes peas is 1 or greater. But what this means is, well, Charles does, or Gene does, or Logan does, and provided we're using an inclusive or, that just amounts to at least one of them does. All right, now consider this one. No more than one of Charles, Gene, and Logan likes peas. So no more than one means maybe none of them do, but not more than one of them does. It can't be the case that 2 or more of them do. This is tricky, and there are a number of ways to approach the problem. If you think about this, you might come up with your own answer. But here's one approach. You might say, well, if it can't be the case that 2 or more of them do, then it can't be the case that Charles and Gene both do. And it can't be the case that Gene and Logan both do. And it can't be the case that Charles and Logan both do. That is, It's not the case that at least two of them do. No more than one of them do. Carnap says that's logically equivalent to a standard translation. I forget what I typed in as the right answer when I put this together in Carnap. But that'll do. And I'm sure there are other ways to do it, because I came up with something a little bit different when I put this problem set together. But this sentence can illustrate to you how we can start to translate more complicated sentences in SL. We can translate really complicated sentences once we start to use combinations of the connectives that we have available to us. And if you try to work through this problem set, go back, revisit the video, see if you would have translated it the way I did, see if you would have come up with something different. If you have questions about it, drop by the study session.